Okay, a car travelling at constant speed this time, which Newton's first law tells us must mean all of the forces acting on it are balanced. So our weight is going to be exactly the same as before, acting downwards, as is the reaction. This time though, the thrust acting on the car exactly equally balanced out by the friction of the road and of the air on it. Now, slightly upping the challenge with our heist calculations, we've been given a speed, we want momentum. The relationship is that momentum is a product of mass and velocity. Clue for this is it's told us it's the same car from earlier on, so its mass has not changed. That's still 1,300 kilograms, and our velocity of 31 means we're going to have a momentum of 40,300 kilogram meters per second. That value is going to come in handy for the next question because it mentions the car approaches a junction and slows down, and we want the force. Now, there's a couple of ways around this. You could work out the acceleration and then use F equals ma to work out the force from it, or you can use the equation that's already put those two equations together. Force is equal to change in momentum, so mass times final velocity, take away mass times initial velocity, divided by time. That's good for us because we've already got what the final velocity is going to be by taking the 31, and we know it's going to get to 6 meters per second. So 31 multiplied by 6 is going to give us an answer of 7,800. And its initial velocity, well, it was this. So its initial momentum is that. It took 6 seconds for that change to occur. The change in momentum is going to be a negative value because it's slowing down. If you're losing speed, you're also losing momentum. And the force, therefore, is going to be negative because, well, it's acting in the opposite direction because it was slowing it down. Now, if you whack that into a calculator, you're going to get a value that repeats forever. So let's round it to a sensible number of significant figures. The most we had in the question was 2, so let's not go above 2. That's my first significant figure. The 5, that's my second. The 4, my third figure isn't significant and it's less than 5, so we're rounding down. So 5 and 4 are significant, but we've got to remember that this was in the thousands, so those round to 2 zeros. A negative force pushed the car backwards. Moving on to the next question then. It looks like a lot of hard work, but actually it is telling us the same change in momentum is happening, going from 31 meters per second to 6 meters per second. All that is different is the time. So we can still use force is equal to change in momentum divided by time. We know our change in momentum is going to be the same as the question before. The only thing that is different is it's happening over 1 second. So we've got 6 times greater a force experienced by that, and we'll build on that idea that the time taken for momentum to change affects the force in our future lessons.